In today's class, we are going to talk about atoms, elements, and the periodic table. Atoms are the basic building block of all matter. But what is matter? I'm sure you heard of that term before. For example, the three states of matter: gas, liquid, and solid. Matter is anything that has a mass and volume. Mass is a measure of the amount of matter that an object contains, which is different from weight that depends on the gravity. And volume, well, not that volume, this volume, which is the space occupied by a substance. So, as we saw before, atoms are the building blocks of all matter. Different types of atoms are called elements, like the ones you know from the periodic table, and two or more elements can join to form molecules and compounds. Now, the atomic model has changed with our understanding of science. Back in 1803, Dalton drew upon the ancient Greek idea of spherical atoms, which in Greek means indivisible, and recognized that those of a given element are identical and differ from other elements. Dalton's mistake was being too simplistic. Thomson, in 1904, recognized that electrons are subatomic components of atoms that are scattered throughout a spherical cloud of positive charges. He even won a Nobel Prize for this. His mistake was not accounting for an atomic nucleus. Then came Rutherford in 1911, who realized experimentally that atoms have positively charged nucleus and electrons orbit around. But he couldn't explain how the electrons moved around the nucleus. Bohr, in 1913, modified Rutherford's model by stating that electrons moved around the nucleus in orbits of fixed distances and also energies, and this energy would not change, so they could not move to a different orbit. This idea was important to explain the emission light of some elements when heated. And finally came Schrödinger in 1926. Schrödinger showed that electrons don't move around the nucleus in fixed orbits, but rather they move in waves, so their position is rather uncertain. So he proposed that there is an electron cloud around the nucleus where we can find electrons, but never know exactly where they are. When we compare these models, we see an evolution from simple to complex explanatory models that shaped our understanding of atoms today. So, in the structure of the atoms we can find the nucleus at the very center. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines its physical properties. No two different elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other because they have opposite charge, so atoms usually have equal number of these particles. As you see here, different elements have different nucleus, different number of protons and electrons. Each element has its own atomic symbol, and the mass number of that element is the total number of protons and electrons in a nucleus. And only the number of protons is what we call atomic number, and is used to locate that element in the periodic table, as we will see in a minute. Consequently, the number of electrons is the same as the number of protons. Take, for example, the carbon atom. How many neutrons does it have? So we know that it has 6 protons from the atomic number, and we know that the nucleus has 12 particles total. So that must leave us with 6 neutrons. And since we have the 6 protons, we have 6 electrons around the nucleus. It can also happen that in nature, the same element has different number of neutrons in the nucleus for the same number of protons, like carbon 12, 13, and 14. These are called isotopes because they have the same number of protons, therefore the same atomic number, but different mass numbers because the nucleus has different number of neutrons. Isotopes are important because they help understand the origins of the universe and Earth, and they have different applications like medicine, agriculture, and industry. When we compare the natural abundance of elements in the Earth's crust and in the human body, we see that oxygen is the main element, but the remainder elements vary a lot. For example, we have a lot of carbon, hydrogen, and nitrogen, while the Earth has abundance of silicon and metals like aluminum and iron. Now let's talk about the periodic table of elements. It was developed by Dmitry Mendeleev in 1869, who initially arranged all the known elements by their atomic mass and placed them in rows and columns according to the similar properties. Today, elements are organized in the periodic table by increasing atomic number. It is organized in periods from left to right and groups from top to bottom. Lighter elements are at the top and heavier elements at the bottom. And remember guys, sanitize your hands, put on a face mask, and keep social distance.